and thank you, Asta, very much for inviting us and for giving us an opportunity to tell you what we are up to in Czech Republic when it comes to EOSC. When I say us, I actually mean my dear colleagues, Niky, Marek, and Michal. We are from Masaryk University and from Herovský Institute, Brno and Prague. And yeah, I've a little bit decided to hijack the session a little bit in the sense that I will, of course, talk about EOSC. And in the EOSC, I was spoiled that we are going to prepare something that we call national repository. And we want stuff to be findable. And for being findable, we have to do metadata. So actually, in the second half of the talk, I would like to talk about how we are thinking about metadata. And I would actually like to encourage people to argue with me later in the chat and so on, because we are really want to in a phase where we are close to start actually doing it. And so any feedback on our decisions that I'm going to present will be super welcome. Okay, now even a little bit, one more little detour, because this is I would like to explain what AccessNet is. This is something that you will see often on my slides and something that you probably might have already noticed throughout the week. I saw it on a couple of slides. So AccessNet is a Czech, basically a backbone to the academic network. It's already nearly already 30 years old, started actually shortly after the country was established. And the original mission was more or less to do the connection between institutes. But services over the years piled up, so it started to do also run a federation of computing centers, because every university or many universities within the country have their own power horses, compute centers, and then we wanted to share them and so on. So there needed to be means of communication and data transfers and so on. So the network, for instance, is pretty fast. It's operating at 50 gigabits today. Just to give you a perspective, if you are in a new offices, then most likely the interconnection is 10 gigabits. So this is 55 times larger. And it basically, the country is already small, and it even shrinks it now to even smaller. The geographical distance is now steered away. I sometimes say as a joke that it's actually faster for me to transfer my data set from Brno to Pilsen, which is from here to here, than to put it on a key and go to the next door office and upload it there on the computer. Just the transfer is really, really fast. And the things piled up, as I said. One of the recently added stuff is what I like to call them this click and enjoy packages. You will hear about it later today. This BioImaging analysis desktop, remote desktop, has been recently deployed at AccessNet. So basically, every researcher in a country can go to log into the AccessNet stuff, click, and it gets deployed on some computer, and then they can use it. Now, coming to EOSC. So from the bird eye perspective, like from the top, when I looked at the official specification, what we updo, it actually makes a lot of sense, I would say. It seems to be that, I mean, it is of course for the connection, but it's also for the number crunching, I would say, because that's what you want to do at the end of the day with your image data. So there are three, I would say, key players, but it's not only on these three guys. There's actually already more than 70 research institutes connected through that and involved in that. These are centers where you can find powerful computers. This Metacentrum is this federation of these like normal clusters across the country. And if you want to do computation or processing of your image data that are maybe remote, what you need to have is also some transportation mean, and with that usually also comes some storage and stuff like that. If you want to deposit your data somewhere that that people later could be able to find it, then you have to also think about metadata. And with metadata, most of us maybe get scared because this can easily end up as a never-ending list of questions that you have to put there. Who is the author and when it was created, and what is the license, and what was image, and you can imagine. So if you are actually going along that a little bit smarter and then plan and do this data management plan and have this electronic logbooks and stuff like that, if you are in the AccessNet, when you log in, then AccessNet already knows a lot about you and can provide this on behalf of you. So this way you can actually make it less of a pain. And so the EOSC is basically built or focusing on these sort of main three pillars. Today, when I look at the webpage, it says that there's nearly 500 researchers, but I checked, it's counting people several times, depending on which working group you are in. I checked a couple of names, and the statistics was that most of them were at least in 3 groups, some of them in 4. So I would say 150 research assist, maybe a better guess. Now, from the sort of a processing or organization point of view, so this is more like the mission, but now how this is executed. So there are several units. I call them units, execution units. We have this headquarters, basically secretariat, which is doing the management coordination PR, but it's not only where it ends. We of course have all this, code of conduct, DEI. We have, I'm not sure if we have some ombudsman, but we have people there to who you can come and complain if you need to. So all the processes are transparent, explained, documented. You know what to expect, you know where you are in terms of time progress and so on. And another sort of a soft skill is this training and support. This data steward is the obvious role, but I'm a computer guy, so I more enjoy the technical part of the units. And the units are basically as follows. This is a big picture that what we are up to. So we eventually would like to create this national repository. This is based or implemented with something that we call National Repository Platform. And then you can have several of them. They each is taking care of its own topic of what they care about. There is some front end connected to it because the front end has this specific metadata, right? Each topic has a different list of metadata. And on top of that is this, I call it big search bar, but it's officially called National Metadata Directory. This is where you come. This is where you start query, and it at the end, at the backend needs to communicate and go over all the available metadata and figure out what's up there in these individual instances. And these instances, they are designed by smart engineers. These are basically spread across people who are in these expert groups. But if you were to ask like what sort of an instances should be there, for that there was I think it was last year or year before, there was a call for working groups. A lot of people applied. Then there came some group analysis, and basically what came out is this sort of a 7 topic groups. And so this is how we are now grouped, and this is what it's probably to be expected that at least 7 repositories will come out of that. Then we have one group which is a little bit special. It's sensitive data. You could totally see that the sensitive data could be in any of these. I always like to think of it as if you think about this parallel, like if these are about to build up a plane, some sorts of different planes, these guys are building a space shuttle. And so you can imagine, you would probably argue with me that agree with me that to build a space shuttle is a procedure where one has to be more careful, right? And everything needs to be triple checked. It's kind of more, things are taken more seriously. So that's why we put it into a special group. When it comes to the platforms, so there is something like a template infrastructure that each platform will use. At the moment, there are 3 of them. One is this Clarity space, which is mostly focused on the language resources, and unfortunately, that's all I know about it. The other one comes from the National Library of Technology. It's for the bibliographic records, and as far as I understood it, it's also for like say you have your data already published somewhere where the metadata that you can attach to that is maybe insufficient. So you maybe want to give it another chance and have your metadata really fully according to the protocol, according to what we are up to. But this is a piece of data that you cannot attach to the original source. So you basically can put it here and have it linked to where your data already is, right? So that you don't duplicate. So that I understood is also one of the functionality. The other one is testnet in venue. For that I have an extra slide. And then there's like a lot of other stuff. This system should be not closed, not because of sort of an inclusivity and like not think about the humans now, think about technology. Something might come out sooner or later, and we would like to have it. Even the people might change in the team, so it's good to have everything documented, to have requirements, to have specification, everything. It's welcoming to have come to pull in another solution, and there's a set of requirements, and it's not only technicals, right? It's because this is for long-term storage, so there needs to be a team of experts. It should not be just a skilled postdoc who 4 years later will disappear, and then there will be no one in the group taking care of that subsystem. So it should be really taken seriously. And then there are numerous of supporting subsystems and people taking care of that. like persistent identifiers or the catalog of these instances, right? If we have several instances running, we need to be aware where they are and how to get them, how to get to them, and so on. Since I put this platform on a special slide, you can probably imagine that this is something special for us. This is really, I would say that's the main workhorse. This is actually how we plan, or where we plan to keep most of the data, especially for the image data. This is true. That's where through this we are going to use this. Yeah, I put here I shouted here a couple of keywords. It's really nice. It has all the good stuff, I would say. Was originally developed in CERN, and we call it CESNet Invenio because it was taken or adopted at CESNet and modified there and adopted because CESNet has its own, ways of storing and plans and so on. So they needed to adapt it a little bit. At the moment, you can find Zenodo operating it at the version 12. So I think it's a pretty robust, stable thing. From my perspective, what is interesting is that it supports connections to ontologies and to hierarchical metadata, so that I couldn't go eventually crazy and have fun there. It has support for S3 and so on. I'm not going to, for the sake of time, name it, but you can look it up. Now, yeah, I mean, this is the picture I've taken from the official documentation. It's usually something to start with, but I thought that it's maybe better now after you understand that we are up to some thematic repositories. So this would be basically here. They are, of course, storing the data on some systems. These systems can be sharing the storage. That sounds very much like CESNet. But if you want to take the Invenio and deploy it on your site, on your university, on your own hardware, on your own connection and so on, that's totally possible. And on these repositories, they also do this metadata stuff and everything. So they, of course, all of them talk to this big search bar thingy, and there needs to be a catalog of them. It's ready for a future extension. And in this year, it is planned that 5, I'm actually not sure about these 3, but the catch-all and the biological image data are planned this year to come to being, actually summer-ish. So we're already having meetings and starting talking really technical and basically the metadata model that I will now start talking about. We would like to convert into a lot of JSON files and have these schemas and all these things, because I of course forgot to say, but I think it's obvious. All these should be sort of machine friendly and API based on the API and so on, so that the whole thing can work. All right. So now let's switch gears. Let's forget about pixels for a moment and think about metadata when we are storing them. It's for the F letter of the whole of the term. The idea is that the data will be hierarchical that you can think of it as layers or levels. I have here this example to demonstrate that the idea is basically that different fields have a different data that have a specific that you want to describe. So there is hardly will be ever one big metadata specification that would fit all of them. So basically, we're thinking of it and incrementally. If I, for instance, would like to describe a transportation vehicle, I might put here a couple of things that are common to any vehicles. But as soon as my vehicle is a plane, or the other time a ship, then suddenly different parameters are to be described, and that this can go on. And it seems to be a tree structure. Basically, the idea is that if you are on the query side, if you start looking for stuff, as you are specifying your query, you will be basically falling through the tree to eventually to land somewhere close by where your data is, or where relevant hits can be found. That's more accurate. If we bring it to the like realistic world, so in Czech, the idea is that the first level will be same for all the metadata for all the topics. And this is something that we call Czech core metadata model. And it more or less is annotation that says who was the author, what was the institution, what is the license when this was created, and things like that. Something that is probably to be attached to any piece of data, doesn't matter what field it is. I try to create here some examples, but if we go the imaging path, then the next layer, the next kind of more details that we want to be collecting is, of course, the RAMBI model. We are not going to, we hope not to reinvent any wheel. We would like to follow. I was actually pretty excited on, I think it was a Tuesday when this was funding guide session. I was following, I saw that there are others who are, I would say, one layer further. So that's good. We have somebody to follow and friends friends in crying in this. So for the pilot run this summer, we are basically thinking of stopping somewhere here, really just do only the RAMBI and see how it feels, because we are afraid that we will need to do a miniature changes to the RAMBI, and that's what I would like to discuss. I hope I still have a bit of a time. Yes. So what is this CCM? This check core metadata model, like to be complete, it's based on this DCAT. That's the catalog of data. It's the EU thing. Basically, my understanding is that every research founded within European Union and that is published, that is up there. Here actually should be said for public data sets, the vocabulary for describing public data sets. So everything that's public and coming from the EU money has to be at least annotated with this DCAT. And the check profile for that exists. And it's pretty much the basis of this core metadata, if it is not exactly the same. To give you an idea what you can find there, it's the obvious stuff. You give a name of a catalog. This catalog can consist of several data sets, and the data sets are somehow distributed. And then I put here, for an example, the contact point. It may sound as a one item, but this is actually a structured information on its own. So it might look easy, but if you were to sort of click on this, it will, list, and then you will put there the institution and a name and such. So it sounds like a couple of things, but can expand and can provide more detailistic questions. So that's more like the topics. Now for the RAMBI, we are now going towards the images. So this is the next layer. After you identify yourself, we want to talk about the images. We are going to follow the RAMBI. So this is the picture that I think everybody knows today. It has a mandatory and optional stuff. So we thought, let's start easy, and we focus only on the mandatory for the beginning. For instance, here in the optional stuff, there is analyze data, and you describe how you analyzed your data, and there's like a bunch of workflow solutions out there. And so we're a little bit waiting how this evolves and how these solutions will be described. So let's wait a little bit and then go with the mandatory stuff for now. And this is the picture that's from the publication, but the BioImg archive is already running its version of RAMBI. They call it 1.5, and it's, if you look carefully, it is tiny bit different to what is in the paper. It's roughly the same, but there are details. There are always details, So this is how I like to think about it. So there is this like an overall field study where you basically query or sort of an envelope to the whole thing, and then you can have several study components, which are the individual pieces of data that you have there. Think of an images or image arrays. You have a biosample which explains what is being imaged on those, but it doesn't necessarily have to be attached to all of them. And some of them can be sharing the biosample. Like imagine you have the same specimen imaged with, I don't know, one microscope, and then maybe you plug it into another microscope and you get another piece of data of the same thing. So what the point here is that these individual elements, they don't have to match like in one-to-one mapping. You can have the situation where you have no biosample attached. That's maybe for the process data. And then you can have a one biosample explaining several study components and so on. Specimen is a little bit of a puzzle for me. It's there, but yeah, let's look closer on these. I have last 3 slides here about these components. The idea is always that the stuff in blue is what we are actually going to put on the website, and this is the type of metadata that we are going to collect. And we already have to be a little different from the official RAMBI here, because the RAMBI, when you look at this, it starts with querying like who is the author, what is the license, founding body, and so on, that we already have in the CCMM, in this check core metadata model. So therefore, we are not going to ask for that. So from the remaining fields in the study component is just the study type. There we obviously want to go ontologies as much as we can. And we are thinking that we will use the EDAM ontology for the biological studies and the mesh for the medical. Actually, the slides that I have here, these slides I was showing to facility people some 3 weeks back, and that's why there is this works for you, because I dare to give them a homework. I basically asked them, I explained them all of this, and then I asked them, like, okay, now when you get home, can you please open up the EDAM and try to find the stuff that goes through your facility? Can you find the answers for that? Can you find it there? Can we say that the EDAM it would be complete for what you are up to? So because I'm a computer guy, so I'm not sure. I noticed throughout the week in the chat, somebody put there a sentence that the EDAM so far works happily for them. This was a very good piece of information for me. Grateful for that. So yeah, so this is what we plan. And at the end of the presentation, there's there's a QR code for a presentation where you will see exactly these 3 slides. And I welcome you to go there and comment on them if you have an opinion or disagree with something. That would be really useful feedback for us. So now what we are going to ask our people, besides the CCM, is the study type. This is also useful for this big search bar at the beginning. That kind of the search bar will now know where to route you for further questions. Then the study components, there can be many of them. Examples. Basically, this we are following here the REMBI, I think, as it is there. That means you give it sort of for each study component, you give it a sort of a handle, a short name, and a description. All of that is a free string, no ontology. For the biosample, it becomes a little bit difficult for us. The official specification has all these organism, scientific name, common name, biological entity, and so on. And next to it, there is a specimen, another blob, which is made of 2 items. All of them are free text, and it's suggested that here you put a lot of text, and this is more or less the materials and methods section as you are used to from the papers. And I had the feeling that this is to a great extent overlapping with this. It's redundant and so on. So we are actually thinking that we will not use these and encourage people to put here the stuff. I mean, this is a little bit dangerous game because not always there is a paper and materials methods around, but let's see how that evolves. Yeah, and then NCBI as a ontology for the taxonomy of what is the biosample. And this is more like a memo for me. If you think about this image, this is supposed to do this sort of a links so that we know this biosample, what study component this is describing. I'm already late. So image acquisition on this is very much REMBI, I think. Except that the imaging instrument, I think the idea was there that originally that there would be a free text. We are thinking of controlled vocabulary. There are options out there. So this is a little bit undecided. Even for the imaging method, we were asking and discussing with the facility people, shall we go a little bit easy? If you look at the website of Euro-BioImaging access, there is a little bit of splitting on very big categories, and we were thinking, is this enough, or shall we go in more fine-tuned level, which would have been the FBBI? And a similar idea was with the imaging instrument. Should we go BINA, which I think we will eventually end up there, but maybe for the beginning, we realized that the facilities are using off-shell microscopes, like products, with some fine-tuning, so that doesn't feel like there's infinite number of them, so maybe we would manage to catalog. And the image acquisition parameters for the beginning, we say just free text. I think there is a good culture in that, so it's probably to be expected that people will put their reasonable answers. Okay, and that's all to my presentation.